Okay, let's try this one. So again, I look at the y's. Remember, you're always zeroing the y's. Now, I could do substitution, or I could do elimination. So I'm going to pick elimination because I'm going to multiply this top one by -1. And what that does, it changes this to positive y, and I have a negative y. There's elimination. So I get negative 6x squared plus x plus y equals 1. Now I don't have to touch that, so because I don't want to change it. Okay, now everything lines up. So now I add these together. So I get negative 2x squared, negative 3x. That's eliminated. That's what I wanted to do. And I get negative 5, so move that over. So negative 2x squared minus 3x plus 5 equals 0. So now we go to our quad program. And we get what? Well, let's see if we can just do some triple play. So let's just times this by -1. So we get 2x squared plus 3x minus 5. It's easier to triple play in positives. So we get 2x. Multiply this outside, so it's -10. Numbers that multiply to 10 and add to 3, so 5 and 2. It's positive, it's negative. This is all over 2, or triple play. That divides into that. So I get 2x plus 5, x minus 1. And so our roots are negative 5 over 2 and 1. So now we know our x's are negative 5 over 2, and the other x is 1. Now to get the y's, I need to substitute them into one of the systems. So I substituted into the first one. So let's do the second one. Let's substitute into this one. It doesn't really matter which one you substitute it. So I go 4 negative 5 over 2 squared minus 4 negative 5 over 2 plus 6 equals y, because I want to move that over to isolate the y. So that means I move this back over. And we type that all in and we get an answer. I'm not going to go through it because you guys know how to type in. And the same thing now, I put the 1 into there and the 1 in there, and I repeat to get those two answers. Okay? All right, so 2 paths of an alley-oop are by these two systems. So now we are going to solve this one. So the best way to solve this, again, let's look at a visual picture, because when we're dealing with real-life situations, it's nice to work with a real picture. Okay, so there we got one person, and standing beside that person is the person that's going to pass, the person that's going to dunk. So there's the ball. So there's the gym floor, we'll call the x-axis, and this is the y-axis. Over here somewhere is your basketball hoop. All right, so that's suspending against the gym wall. All right, so we know the flight of the ball is going to go up and do something like that, right? And the person has to run and take a flight. So that, okay, because you have to run, leap, and catch the ball. So now we're trying to find those intersection points where the person catches it and slam dunks it. That's what an alley-oop is when you catch and slam dunk it. So you have two places that this can happen. Okay, so how are we going to do this? Well, we have two systems. So we have d squared minus 2d plus 3h equals 9. This one we have 5d squared minus 10d plus h equals 0. So see how I lined everything up? H is on h, d is with d squared, d squared. Okay, so we want to get rid of this h. So this is a positive 3h. So if we multiply this by negative 3, this whole system, we're going to create a negative 3h. So we have negative 15d squared. And we have positive 30d minus 3h equals 0. And the other one we don't have to touch. So just bring it down. Okay. Now we're going to add those up. So there's our elimination, which we wanted. So we have negative 14 . All right. Now we're going to move this over. And because we're dealing with big numbers, we just type it into the quad program. And what comes out of the quad program is 0.402. And the other one was 1.598. Now we just need to get the y values. So we just substitute it into one of the systems. So it's probably easier to substitute in this one. There's an h we can get by itself. So taking these points right here, substituting this into that d, and out plops 3.21 and the same thing there. Okay, so now what does that mean? Interpret. Well, it means that, going back to our little diagram, this is our time, or pardon me, it's my time, and this is my height. So at this point here, it's half a second, and he's at a height of 3.21 meters. And this one here is there. It's 1.598 seconds, and it's a height of 2.1. Okay, so that's it. Okay, the last one, this is sort of a higher mental processing question, and it's actually not that difficult if we know a couple formulas and we can solve. So let's look at this. So write two equations for the area of the bottom. Okay, so we know the area of the bottom. They gave it to us, so we'll say A is area is 35. So there's one system, A equals 35. Now, they gave us some dimensions, so we're going to use these dimensions. So we know the area is length times width. We did that way back in probably middle school. Okay, so what is the length of this bottom? Remember, we're dealing with the bottom. This section right here. Okay, so how far is the length from there to there? Well, we know the whole thing is 8, and there's a little x here, and there's obviously an x there. So we know it's 8, take away 2x. Okay, what's the width? This piece right here. Well, we know it's 6, and there's an x there, and there's an x there. So it's 6, take away 2x. So now we have our two systems. There's system 1. There's system 2. So there's our two equations. Now to find the dimensions, we're going to have to do some math. Well, so let's just rainbow this out and see what we get. So if we rainbow that out, we will get 48 negative 16x negative 12x positive 4x squared. Okay, so let's collect like terms. So we get the area, let's put it in order, and then we get negative 28x, and we have plus 48, and the other one we knew was 35. Now to get the dimensions, we can solve for x now. We'll just use substitution because there's a and there's a, so that's just going to go in there. So we have 35 equals 4x squared minus, so that's 4x squared, so that's going to go join that. So what do we get? 13, and then we quad that, and when we quad it, what comes out was 6.5 and 0.5. 6.5 and 0.5. Those came out of the calculator. And just looking at our dimensions, well, 6.5, this is x equals, this is x equals. That's this piece right here. It can't be 6.5 because it's too big for that. So these are 0.5s. So these are 0.5s. So our dimensions are going to be a 0.5 and a 0.5. So that's 1. So that's 5. And a 0.5 and a 0.5, which is 1. So that is 7. So our dimensions are 5, 5, 7. Which makes sense, because what's 5 times 7? It's 35.